Hello and welcome, and in this video I'm going to show you how you can solve quadratic inequalities. Previously, I've explained how you can solve linear inequalities like this one by solving it as if it were a normal algebraic equation like this and being left with the inequality. Quadratic inequalities act a bit different as they have an x squared term. So step one is we need to factorize the quadratic. So in this case, in factorized form, we will get x plus 7 and x minus 3. If you are unfamiliar with factorizing quadratics, I can link a video where I explain how to do them in the description down below. So once we have our factorized form of the quadratic with the inequality, what I would like to do is solve the quadratic. Now, solving the quadratic just needs one more step, and it means we need to set each of these brackets equal to 0. So what does that mean? That means x plus 7 is equal to 0, and x minus 3 is equal to 0. And now we just solve for x on each case, okay? So x would be equal to minus 7, but x would also be equal to 3, okay? And here are our solutions to the quadratic. This is different to our factorized form because we are equating x to 0. And as you can see, the solutions are the opposite of what is in the bracket. So that's a good trick as well. Now once we have our solutions for our x terms, I will draw a number line for visualization. So we have x, 3, we'll write 3 up here, and x is minus 7 all the way down here. And our number line goes to negative infinity to positive infinity, okay? So, Now, how can we show this quadratic in a number line? Well, we know that a quadratic, the shape of a quadratic on a graph like this, will typically look like a curve like this, or will look like a concave down curve. So, as we can see here, there are 2 points in which it crosses the x-axis, okay? And these 2 points are our solutions to our quadratic. These are what these numbers tell us on a graph, okay? We don't need to know so much about that now, but what we need to know is that our graph on the right side of this point is positive. As you can see, it's above the x-axis. This point is all negative, and this point is positive again, okay? That is a good thing to remember. And here it's reversed, so negative, positive, and negative. So how do we know which type of quadratic it is? Is it a positive one or is it a negative one? So we can find which type of quadratic it is by plugging in a value for x into our original quadratic. So if we plug in a number between minus 7 and 3, we will know whether this will be positive or negative. Here, let me explain. So x squared plus 4x minus 21. If we plug in x is equal to 1, right, because 1 is between negative 7 and 3, we get 1 squared plus 4 times by 1 minus 21. That will give us 1 plus 4 minus 21, and that will give us minus 16. Yep. So, what does this tell us? This sign, we don't really care what the number is, but what we care about is the sign right here. This is a negative number, okay? Meaning that in between these 2 points, it is negative. So it cannot be this quadratic, it has to be this type of quadratic. So this in between here is negative, and then we know that here is positive and here is positive. Great. The last step, once we know our inequalities for the quadratic, is to find what x values will give us this inequality. So x squared plus 4x minus 21 is less than 0. So the question is, what value of x will give us a number that is less than 0, okay? So the number can be positive, what we plug in for x, but the result of this has to be less than 0, meaning it has to be a negative number. So we know that our values of x terms that we can use has to fall in this area. because these are our negative results. So if we plug in any number from -7 to 3, we will get negative results. Now, this inequality is not an equal to or less than. It's only a less than. So we need to exclude these two terms. So we're going to have x is more than -7 and less than 3, right? So if we were to plug in any number greater than -7 and less than 3, we would get a negative result that is less than 0. So our inequality for the quadratic would be this right here. Let's take a look at another example. Here we have -x squared minus 2x plus 8 is greater or equal to 0. Now what I'm going to do first is I'm going to simplify this or factorize it. And I'm going to factorize this negative sign, okay? So negative x squared plus 2x minus 8. That is the same thing as this quadratic, just a little bit simpler to look at. So I'm going to factorize this inner quadratic and just ignore the negative sign for now. So I'm going to get x plus 4 and x minus 2, okay? Now I'm going to solve this factorized form of the quadratic. So I'm going to get negative x plus 4 is equal to 0 and negative x minus 2 is equal to 0. So I will get negative x negative 4 is equal to 0. I just expand the bracket. Then I'm going to get negative x is equal to 4 and divide by -1, which would be x is equal to -4. That's one solution to our quadratic. The other is negative x plus 2 is equal to 0. Negative x is equal to -2, and x is equal to 2. So here are our two solutions for the quadratic. Coming back to our quadratics, remember we have the positive ones and the negative ones, or concave up and concave down as they're usually called. So we have our two solutions, so our 2 points that it crosses the x-axis, but we don't know whether it's a concave up or concave down quadratic. So the next step is drawing our number line here. So from -infinity to +infinity, and we have -4 and 2, okay? So we need to plug in values that are in between -4 and 2. So I'm going to plug in x is equal to 1. That's nice and easy. So we're going to plug in -1 squared minus 2 times by 1 plus 8. So we get 1 times 1 is 1 times by -1, so that's -1 minus 2 plus 8. So 8 minus 3 is 5. Okay, and that is a positive result. Okay, so we know that this middle area, the section between -4 and 2, is positive. So that must mean that beside them is negative. So in this case, this is negative and these two are positive, but this is positive in the middle and these are negative. So we know it is this type of quadratic right here. Now we need to look back at our original quadratic. So we have -x squared minus 2x plus 8 is greater or equal to 0. Now we have greater or equal to 0. So that must mean it could be equal to 0 and any positive number. Okay, so here are positive values in between -4 and 2, but it's also equal to 0. So these 2 points, by the way, are 0, right? They're not negative, they're not positive, they're at 0. So that means we can include -4 and 2 in our inequality. So we're going to get -4x. So x is greater or equal to -4 and is less than or equal to 2. And that would be our inequality. Thank you for watching, and I'll see you all in the next one.